Question 11, we have a particle of mass 8 describing a circle with constant speed v on a smooth horizontal table. Connected by a light inextensible string, 3 meters on, 3 meters, 8 kilograms, 8g. It's on the table, so there's a reaction at the table. And my radius, and I have a 1 meter here, so the radius is the square root of 3 squared minus 1 squared. You should have to just write down root 8, square root of 3 squared minus 1 squared. So put my a in, so sine a is equal to 1 over 3. So my force in this direction is, in terms of t, is equal to t over 3. Put t on, cos a is equal to a over h root 8 over 3. So my force in this direction is root 8 times t over 3. And we're asked to show that the tension is given by this guy, 3v squared is equal to t. So let me see, my force is now R plus t over 3, both going up, is equal to 8g. And then we're dealing in terms of v here, so I have mv squared over R for the centripetal force, so root 8t over 3 is equal to m, which is 8, times v squared over my radius, which is root 8. So cross multiplying in this direction, or multiplying both sides by root 8, we're going to get 8t over 3 is equal to 8v squared. So t dividing by 8t over 3 is equal to v squared. So t will be equal to 3v squared, which is what we're asked to show. Show that the particle will remain in contact with the table if v is less than the square root of 8g. Okay, let's get this. We don't need the reaction force then, do we? We have the hg going down. If hg is equal to, well, if hg, if it's greater than what's going up, it'll stay on the table. If hg is greater than my upward force of t over 3, it will stay on the table. So hg, if it's greater than t, which is 3v squared over 3, will stay on the table. hg would have to be greater than v squared, so v squared would have to be less than hg, so v would have to be less than the square root of hg. So that's correct for it to stay on the table. And then if the speed is increased to root 9.1g, calculate the height at which it rotates. So it's moving up off the table. So just create this diagram. The string is still 3, it's just up a bit higher. We have a, we have t, so this is going to be t sine a. And actually I might just show it in terms of x and y. This is y and this is x. Sine a is equal to y over 3. So 3 sine a is equal to my y direction, and the force in that direction is going to be 3 sine a times t. And similarly, we're going to get x is going to be 3 cos a. So the force in this direction will be 3 cos a times t. Okay, where's this going? We have speed. We're being told the speed. So maybe solve for t in both directions. Let's have a look here. So we still have our 8g coming down, and we have this force going up. It's off the table now. So 8g will be equal to this one, 3 sine a times t. I'll just leave it like that for a minute. I think t is the only thing we can get similar with in both forces equations. In this direction, 3 cos A times t is going to be equal to my mv squared over r, and r is x, which is 3 cos A. So 3 cos A, actually I'll get t in both. T in this case will be 8g over 3 sine A, and t in this case, if I divide by 3 sine A and change r to 3 cos A, I'm going to get t is equal to 3 cos A by 3 cos A is 9. It's going to be equal to mv squared over 9 cos squared A. Where's this going? We have m is equal to 8, so I'll put that in as well. Okay, so I have two t's. Let me equate them. 8g over 3 sine A will have to be equal to 8v squared. And we have v, actually they told us v is the square root of 9.1g, so v squared is going to be 9.1g. So 8v squared over 9 cos squared A. I can divide both sides by 8 and by g. So if that becomes 1 and I cross multiply, I'm going to get 9 cos squared A is equal to 3 sine A by 9.1. So if I divide by 3, I get 3 cos squared A. Maybe I'm going in the wrong direction here. 3 cos squared A is equal to 9.1 sine A. Well, actually, we know cos squared A plus sine squared A is equal to 1. So I can replace cos squared A with 1 minus sine squared to get this quadratic in terms of sine. 3 times 1 minus sine squared A. I'll bring the 9.1 sine A to the left. That will be equal to 0. 3 minus 3 sine squared A minus 9.1 sine A is equal to 0. Okay, so what I'm going to do is I'm going to get rid of the decimal and I'm going to multiply by minus 1. So I'm multiplying by minus 10 here. So I'm going to get, I'll start with this one. So I'm going to get 30 sine squared A plus 91 sine A, and then minus this guy by 10, 30 minus 30. Does this factorize? Well, I'm just seeing here 91, so we're going to have to get something near 100. There's a 10 in both of these. Could I divide by 3? I think, no, it doesn't divide by 3. 10 sine A. I'd have to have a 10 here to get 100 sine A, which would leave a 3 here and a 3 sine A. Oh, that does work. So I'm going to get 100 sine A and 9 sine A, which will give me 91 if the signs are like this. So I'm going to get a minus in here, so I'm going to not look at this one. I'm going to get 10 sine A minus 3 is equal to naught. So 10 sine A is equal to 3. So sine A is 3 over 10. Does that help us? Sine A is 3 over 10. What do we get for this height here? We're looking for the height above the ground. So it's something to do with the y. 3 sine A is equal to y. 3 sine A. Do we get 3 over 10? 3 by 3 over 10 is equal to 9 over 10. So that's the height, that's the length. And here's 9 over 10. What was it at the beginning? 1. It was 1. It's now 90 centimeters. So it's 10 centimeters above the ground. What a great question. Get practicing.